Hi guys, so welcome to the last talk of today's. So today Allison Kaptur gonna actually talk us about why we should love bugs. So I know if there's one thing I don't love is bugs, so let's see.
All right, challenge accepted. Can you hear me okay? Great. So I'm Allison Kaptur. Here are some places that you can find me on the internet. This is my handle on Twitter and GitHub, and this is my website. I currently work for Pilot.com, which does bookkeeping for small businesses and tech startups and other companies in San Francisco. Before that, I worked for Dropbox on the desktop client primarily, and before that, I worked for the Recurse Center in New York City. But none of that is important to remember. The only thing you need to know about me is that I love bugs. I love bugs because they're like a murder mystery. It's like veers off in an unexpected direction. You think it's one thing, it turns out it's something else. It's the moment of your day when you're most surprised. And I think that's really fun. So over the course of this talk, I'm going to talk about a couple of bugs that I particularly love and explain why I love them. And then I'm going to try to convince you that you should also love bugs. OK, so let's go ahead and dive straight into bug number 1. This was a bug from my time at Dropbox. So Dropbox, as you may know, is a utility that you can use to sync files from one laptop to the cloud and to another laptop. And this is an architecture diagram of Dropbox, which is vastly simplified. The basic idea is you have the desktop client that is running on your local machine, your laptop or whatever, and it is talking to, for the purposes of this bug, 2 servers at Dropbox. One of them is called the block server, which is where we store the actual file contents, and the other is meta server, which is responsible for metadata and permissions, and in practice, a bunch of other stuff too. So when you are writing to a file, your local client is listening for changes to the file system. And when it detects one, it knows that it should upload those changes. Now, in practice, we don't want to upload the same block to the block server over and over again. So you can imagine if you're writing like a letter or a memo or something, you're probably mostly appending to the end of the file. You don't want to upload the beginning of it more than you have to. So the way that this works is the desktop client will notice a changed file, hash that file in chunks, and then it will check with the meta server to see if the block server already knows about those chunks or not. So block server is effectively a giant key value store, where the keys are the hash of the contents and the value is the contents themselves. So the request response goes something like this. The client says, OK, I have 3 blocks in this changed file with the hashes ABCD, DEF, EFGH. And the meta server would say, OK, I have those first 2, but please upload the 3rd. And then the client will do it. That's a setup. So here's the bug. Sometimes the hash value that we would get from the client would be twice as many characters plus 1 as it should be. And we would see the server would not know how to handle this and would throw an error. So where could this possibly be coming from? We would take a look at the logs on the client, and the logs would inevitably be really strange. Like there would be memory errors coming out of Python, the desktop client's local database would have been corrupted, like all sorts of weird things, crashes unexpectedly. And when you've never seen this bug before, it's very hard to diagnose. And then once you've seen it once, it really jumps out at you. So the character that we would sometimes see in the middle of this hash value, it was effectively the 17th character. Should have been 16 characters, comma, another 16 characters. And instead it would be an L. Or sometimes it would be a left bracket, a $sign, a left paren, a period, a short dash, or one that's unprintable. And basically never anything else. Is that enough of a hint for anyone? Has anyone seen this bug before? Seeing one hand. So the ordinal value of a comma is 44. Ordinal value of an L is 108. And here's the representation of each of those in binary. You'll notice that the comma and the L are exactly 1 bit off. And therein lies your problem, bit flip. So 1 bit in the memory that was storing this comma has flipped from a 0 to a 1. And now instead of a comma, we have an L. And here is a little table with the other possible bit flips and the other characters that we would see. So I love this bug because, first of all, it shows that bit flips are real. This is something that you might have heard about in the sort of theoretical context when you start to think about memory management. But when you're operating at a scale that Dropbox is operating on, you will see it on a reasonably frequent basis. This is not something that is a hypothetical concern. Now, the fun fact about this is learning the difference between what is unlikely and what is impossible. And there are a number of different circumstances where a bit flip is more frequent than you would expect by true randomness. One of those circumstances is where Dropbox is operating, which is a lot of your users are running old hardware. I think Dropbox deprecated Windows XP like 2 or 3 years ago. So we like really pride ourselves on supporting Dropbox for as many people as possible. And so a lot of those computers are not very good. They have random memory corruption. You get a lot of bit flips. Another context where you see a lot of random bit flips is if your code is running in space, because there's no atmosphere to protect you from like energetic particles and stuff. And so if you are in a situation where you really care about correctness, which in space you probably do, like maybe your code is keeping astronauts alive on the International Space Station, maybe your code is doing like advanced scientific research on Mars, even if you're not in a life-supporting operation, it's still really hard to do a software update into space. So if you really care about this, and you really care about not having random memory corruption, there's a bunch of different strategies you can take. Run hardware, software, having redundancy. NASA has a programming language that is oriented around dealing with this problem. Dropbox in this context doesn't really have a problem to solve. And the reason for this is that the corruption is happening on a user's machine. So there's not a ton that we can do about it. We can detect it when this particular bit flip happens to fall in the comma character. But if it falls elsewhere in the hash, or if it's the user's actual underlying data that's corrupted, there's not a lot to do. And so this problem in particular would often clear itself up when the desktop client restarted. The other thing that I really love about this bug is that it's a tremendously social one. One of the reasons for that is because it's so much easier to diagnose it when you've seen it once already, and it's so difficult to diagnose it if you're not thinking that this could be the issue. The other reason why this one was really social was because it can happen anywhere that the client is making a request into the server, which is a lot of different parts of Dropbox, and so a lot of different teams, and so a lot of different engineers would encounter this bug. So this is one that would come up in conversation a lot. I think that's really fun. The other fun thing about this bug is that it's a reminder to talk about the things you're running into and to share what you're finding out. So if you're debugging something complex, especially in a large system with a lot of different pieces of code and a lot of systems interacting, make sure that you're talking about it. It's possible that someone else already knows exactly what's going on and can give you a great hint. If they don't, in some ways that's even better. Just make sure that you circle back when you figured out what the underlying problem was and you like told your team about it. If you can write a blog post, please tell me about your weird bugs. All of that is particularly productive in this kind of an environment. Okay, so I want to talk briefly about how bugs can be useful to you. Before I worked for Dropbox, I worked for the Recurse Center, which is effectively a writer's retreat for programmers in New York City. So people come for a period of time, 6 weeks or 3 months, and they work on getting better as programmers in whatever way is most interesting to them. So people would come in with all sorts of different backgrounds. Maybe they'd been writing Java for 10 years and wanted to learn Clojure, Haskell. Maybe they had been doing embedded systems programming and wanted to move into web development, all sorts of different things. There's no curriculum. There's basically no structure to the Recurse Center at all. So I worked there as a facilitator, helping people kind of make the most of their freedom and figure out what their goals were for learning and how they could best make those happen. And as a facilitation team, we were really interested in discovering how self-motivated adults could have the most effective experience, could get the most learning out of their time. And one of the things that we found out was bugs are great for this. If you hit a bug, and I'm particularly thinking here about a bug that you yourself wrote, that is the best kind of bug. Is a bug that you wrote shows that you're operating right on the edge of your ability. If you can write something perfectly, then you're probably not learning anything new by writing that code. And similarly, if you can't make any progress at all, then you're not even going to get as far as having a bug. But when you have written some code and it has a bug, it tells you that you have some working mental model of your code, but that mental model is imperfect. And even better, the bug is telling you in what way that mental model is imperfect. And so this is an opportunity to correct your mental model of your system, to fine-tune your understanding or possibly change your understanding completely, which is a rare opportunity for us as programmers. Often, if you're trying to get feedback on a decision, it takes weeks or years or potentially never to really understand the consequences of that decision. If you're debugging, you have been given this little test environment that you can use to check your assumptions on a very short time scale. So this is a huge opportunity, and I really encourage you not to let that go to waste. An important part of this is if you kind of let the bug get in the way too much, if you are like ashamed of having the bug, if you're in an environment where it's difficult to admit that you've made mistakes, any of those sorts of things, you're not going to be able to take advantage of this opportunity. And so later on in this talk, I'm going to come back to some ways that you can make sure that you're not letting the opportunity of growth from a bug pass you by. Okay, second bug. This is kind of a story about how several bugs can add up to an unexpected result. This was also a Dropbox. At the time, I was investigating why desktop clients weren't sending up logs to the server as consistently as we expected. And I found a bunch of bugs in the logging system the desktop client was running. Most of them were not important, and I won't mention in this talk. There are a couple that were. So here's, again, a lovely architecture diagram of the logging system. Fairly straightforward. The desktop client is generating logs. Every so often, it would take the logs that it had in memory, compress them, encrypt them, and write them to disk. And then periodically, the client would upload those logs to the log server. The server would decrypt the logs and would store them on the back end for later retrieval. Now, anytime you're designing a system like this, where you're writing logs to your user's machine, you have to make sure you're being respectful of your user's machine, and you don't want to let that directory grow unbounded. So the client also had a check that said, if the log directory is above a certain maximum size, delete files until it isn't. Fine. So bug number 1 and bug number 2 were around this trimming and deletion code. The first bug, which is basically not optimal, not a huge problem, is that when we sent logs up from the client to the server, we sent them starting with the oldest and moving up to the newest. Not a huge deal. In a perfect world, you're going to get all those logs anyway. But strictly speaking, the newer ones are probably more relevant to you than the older ones, so ideally you'd want to reverse that order. Fine. The second problem was if the log directory did get too large on disk, we would delete the files starting with the newest files instead of starting with the oldest. Again, not exactly ideal. You're deleting files either way, so it's not and you don't need perfect coverage on your logs. But the newer ones are probably more relevant, so you probably want those instead. The third component of this bug was on the server. Sometimes the client would make a request to upload a log file to the server, and the server would be unable to decrypt it. And we weren't handling this exception correctly, and so it would cause the server to 500. The client would interpret a 500 in a sensible way and say, okay, the server is down. I will not try to send up any more log files right now. So we find this and we go to fix it, and it's not immediately clear what the right choice is. Like certainly you don't want it to be a 500, right? This is not a server error. So you can make it a 400, signal that this is the client's fault. But it's not like, excuse me, it's not like the client can fix the problem. If the server can't decrypt the log file now, it's never going to be able to decrypt it in the future. So what we really want the client to do is just delete it and move on with its life. And in fact, that's already the behavior when the client uploads a log file successfully. It deletes the one off of disk and moves on with its life. So we said, okay, great. Instead of returning 500, we're going to catch this exception. We'll throw out a quick log to our metrics table so we can keep an eye on the rate of this and notice if it spikes. But otherwise, just return a 200, have the file be deleted, everyone move on. So we make this change. We deploy the server. At the time, we had fixed the other 2 bugs on the client, but those hadn't gone out more broadly to the world. But the server change deployed a couple days later. And when we deploy it, traffic to the logging cluster spikes really dramatically. And the serving team reaches out to my team and is like, hey, do you know what's going on with this cluster? Why is it suddenly getting a ton of traffic? And it takes me a minute to put all the pieces together. Before we had fixed this bug, log files were sent up starting with the oldest. They were deleted starting with the newest. If the server couldn't decrypt one, it would 500. And if the client got a 500, it would stop uploading logs. So if you ever had a log file that was corrupted, the client would try to upload it. The server would 500. The client would give up. An hour or so later, the client would go to upload logs again, try to upload the same corrupted log file, again get a 500, and again give up. Eventually, the log directory would fill up. We would start deleting the newer files, and the corrupted file would remain in place. So effectively, if we ever had a client with a single corrupted log, then we would never see logs from that client again. So this is not great. What was even worse was that there were a lot more clients in that state than we had expected. So basically, we had some clients that had this dam of log files that they were waiting to send, and we had cleared the dam. Okay, so we have this huge flood of traffic that is effectively a DDOS of ourselves by our own desktop clients. Thankfully, it's only against the logging cluster, so this one's not going to lead to a serious incident or outage. But still not a good situation. What do we do? So the first question you always ask yourself when you've done a deploy and things start going sideways is, well, can we roll back? And we asked ourselves that question. And we could have done that. But in this case, it doesn't really help you, because the state transformation that we made that mattered was not the state transformation on the server, but the state transformation on the client. And that one we cannot reverse. So if we had rolled back the server, we would have prevented more clients from getting into the state where they're sending up us all their logs. But for the ones that were already sending logs, rolling back the server wouldn't have changed that. The next question is, can you just scale the cluster? So we did that, and traffic spiked. We did that again, and traffic spiked again. And then we stopped. And the reason why we stopped is because this cluster was not perfectly isolated. It made calls into other clusters. And if you have a DDOS pointed at one cluster, and you just keep scaling it infinitely, now you have a DDOS pointed at every cluster that that one talks to, and now you have 2 or more problems. So we hit the limit on how much we could increase the size of the cluster. The next question is, can we just shed load? Like, these are log files. Some of them are super old. We don't have to get perfect throughput here. Can we just dump traffic? And we could have done that, and we considered that also. The challenge here is we would ideally not like to lose logs from clients that are healthy, that were never in this state. And we can't easily distinguish these ancient log files from the newer ones at the layer where it'd be useful to shed load. By the time you get all the way to the point of being able to figure out how old a log file is, you've basically done all the work, so you might as well go ahead and store it. So shedding load wasn't a great option. Now, one option remains to us, and this is one that I think every Dropbox client engineer has encountered at some point in their career, and that is a header called chill out. You've never heard of chill out because it's a custom header inside of Dropbox, and someone very wise added this to the desktop client in the very early days. And the way it works is every client respects it on every endpoint, and if it gets that header, then it does not make any more requests for the specified number of seconds. And it's to prevent exactly this kind of situation, or to respond to exactly this situation, where you have a DDoS that you pointed at yourselves. We had a minor problem here because the logging cluster was not actually able to set that header. But that's a problem on the server, so that one's easy to solve. So 2 of my colleagues, John Lay and Isaac Goldberg, implemented that. We got that deployed to the serving cluster, and we cranked it up to, I think, 900 seconds, and then gradually managed it down over the next couple of days as that deluge subsided. OK, so what are the lessons from this? The first one is that it's not enough to know your code. You also have to know your system. So in this case, I had a pretty good mental model of the relationship between the server and the client. But I wasn't thinking about what would happen when the state change was affected on tens of millions of clients all at once. So for Dropbox and any system with more than 2 parties, you really need to have a model of the whole system at once. The second lesson is to know your tools. What are you going to do when things are going sideways? And more basically, how do you know if things are going sideways in the first place? Now, this is all about monitoring. It's all about response options. Can you roll back? What tools are available to you in your toolkit? And I would love to say that you should figure this out and make a list, and then you'll be good to go. In practice, everyone finds out what their tools are while things are on fire. And this is, in fact, a great way to learn. When you've learned something under duress like that, then you're not going to forget that that tool is available. The other lesson is a little more practical and lower level, and this is for you if you are designing a desktop application or a mobile application, and that is you really need server-side gating and feature flags. And this is the difference between your response time being 10 minutes while you flip a config on the server and wait for it to propagate, and your response time being 3 weeks while you push out a change and it goes through App Store review. Now, the Dropbox desktop client did not go through an App Store review process, of course, not an App Store app. But this was a couple years ago, circa 2015. Even just pushing out an update to the tens of millions of clients that Dropbox is running on takes significant time, just to get the bits and let them all restart in a way that doesn't DDoS the server again. And so that process took minimally a couple days, practically speaking more like a week, not including QA time and that sort of thing. So being able to have a response that you measure in minutes instead of that you measure in days or weeks is really valuable. This is absolutely not free, as advice goes. It significantly increases the complexity of your code. And in particular, you lose test coverage because you're definitely not testing the full matrix of feature flags. For every feature flag, you have an n-squared problem in your test coverage. And it's also very difficult to get engineers to clean up their feature flags once the feature is fully rolled out, and I was also absolutely guilty of this. And then for the desktop client, you have many versions in the wild at once, and so how do you think about which has which features, and can you remove this on the server? So the complexity overhead is significant. I will be honest about that. But I will say, when you need it, you really need it. Okay, so I've talked about a couple of bugs that I've loved: random memory corruption, self-DDOS. I've given you a little bit of an overview on why you should love bugs. And now I want to tell you how to love bugs. And if you don't love bugs already, I know of only one way to do it, and that's to have a growth mindset. So a growth mindset is based on research by Carol Dweck. And the way it works is that she's got two frameworks for thinking about intelligence. The first one is a growth mindset, which holds that intelligence is fundamentally a malleable thing, that everyone can change it and increase their intelligence by exerting effort. The second framework is a fixed mindset, which says that intelligence is a thing that you have in some quantity, and you can't really affect how much of it you have. And effort is not a factor. So I want to run through a couple of the consequences of this that I think are really interesting. The first one I think is arguably the most famous of her study. It's called Praise That Backfires. And I'm going to skip over the details of the study just in the interest of time. But basically the model is she and her collaborators experimentally induce a fixed mindset in students or a growth mindset. And the fixed mindset is induced by saying, wow, you did so well in this quiz, you must be really smart. And the growth mindset induced by saying, wow, you did so well in this quiz, you must have worked really hard. And then they have a bunch of different findings from this. The first one is, in this setup, the students get to pick whether they want a harder or an easier problem set next. And if the students who were praised for effort, 90% of them wanted the harder problem set next. And the students who were praised for being smart, it was only a third. So huge difference in whether you sign up for a challenge or whether you want to stay in your comfort zone. The second finding was, oh, this is a little cut off. The second finding is around resilience in the face of setbacks. So students would do one problem set, then they had this harder one next, and then they had a third one that was similar in difficulty to the first. And the idea here is that if students are unaffected by the second one, then they should perform about at the same level of competence on the first and the third because they're about the same level of difficulty. And they found that the group that was praised for trying hard did slightly better on the third quiz than they did on the first one, which is what you'd expect. You know, it's your second time doing it. But the group that was praised for being smart did significantly worse. And they did worse because they had struggled on the second one. Their identity of someone who was smart was shaken, and they were not able to recover from that, even when the problems were back in within their own range of ability. The third result is the one that was most surprising to me when I was researching this talk, and I had not heard of previously. And that's that the students were asked to write a letter to a pen pal at the end of the study saying, oh, we did this study in school, and here's the score that I got. And half of the students who were told that they were smart lied about their scores, compared to almost none of the ones who were praised for working hard. So being told that you're smart leads to all of these attempts to continue to appear to be smart, including dishonesty in the face of a pen pal letter, which seems like not very high reward. Another interesting finding is around response to confusion. In this study, the setup is that Dweck and her collaborators are teaching some elementary school students about psychology. They don't have any background in it. They give them a pamphlet. Some pamphlets have a really confusing passage in them. Others don't. And they, again, experimentally induce a fixed or growth mindset. And they try to see what students' mastery is depending on their mindset and whether they face the confusion. So they find that students have about the same level of mastery if they either have a growth mindset or did not have a confusing passage. But for the students who have a fixed mindset and faced confusion, their retention, their overall mastery of this material goes way down. And if you had just ignored the confusing section, you would have done fine on mastery. That part was not important. All you had to do was get past it. And I like this because I have an example of the confusing passage, and I will read that now. How can one best describe the nature of people who will most of all be that way, which will make the imitating of others happen most often? Is it that these are the people we want to be like because they are fine? Or is it that these are the people we want to be liked by? Hands up if you've ever started using a new tool and you've read documentation that sounds like this. Right, super common. So as programmers, it is a critical skill to be able to retain the rest of a document when a part of it doesn't make any sense at all. The final finding I want to talk about is that these theories cause a difference in effort. So if you have a fixed mindset, you believe that if you are good at something, it should be easy for you. And conversely, if something is not easy for you, then you must not be good at it. And so this causes people to be unwilling to work hard, because that would be admitting that they're not good at the thing that they're doing. Whereas if you have a growth mindset, you believe that effort is the way that you grow, and so you are keen to exert effort, you're keen to find challenges, because you know that that's the way to get to the next level. So debugging is a particularly important spot to practice all these principles. If you look at what we just talked about, responding to confusion, retaining information when you have only partial information about your system, admitting what you know and what you don't know, and how things have gone previously, and being willing to tackle something harder even when it's out of your comfort zone. That is basically what debugging is. And so this is a super important area to be practicing this growth mindset framework. So hopefully at this point you're convinced that this is a good thing that you should be using in your programming and in your debugging. And so the next question is it something that you can change? If you have a fixed mindset, can you turn it into a growth mindset? And the answer is you absolutely can. And if you look at these studies, these are very, very subtle ways of inducing a fixed or a growth mindset. It's like two kinds of praise that vary slightly. Some of the other forms of experimentally inducing one mindset or the other were like having students read a very short biography that ends with this person succeeded because they worked so hard, or this person succeeded because they were a genius wizard, etc. So we as humans are like very attuned to subtle cues from this. So you can absolutely develop this. A couple of strategies that I like to use. One is to reframe praise and success. So if someone gives you a compliment and it's the wrong kind of compliment, you can rewrite it for yourself. They're like, wow, great job on that bug, you're such a genius wizard. You can say, oh yeah, that went really well because I worked really hard. You don't necessarily have to do this out loud, that's up to you. And similarly, when you experience some success, you can think about what strategies you used that got you to that success, rather than being like, yes, I succeeded at this because I am awesome. Similarly, you have the flip side of that. What is your self-talk when you have a setback and when you face a failure? If what you're hearing yourself say is, maybe I'm not cut out for this after all, that's a red flag. And you can start to think about ways that you can get a lesson from the setback you had, or like figure out a different strategy for next time. It sounds really cheesy, but it does work. And the third strategy here is to celebrate challenges. And this is something I tried to be really consistent about at the Recurse Center. So someone would come and sit down next to me and they'd go, I think I have a weird Python bug. And I would go, great, I love weird Python bugs. So first of all, definitely true. Please come talk to me about all of your weird Python bugs. But more importantly, it demonstrated to the recursor, to the participant, that hitting a challenge was something to be excited about. It was a sign that they were on the right track, and it was an opportunity to learn something new. I will say that this attitude is basically free at the Recurse Center, where your goal is to get better as a programmer, and you don't have things like deadlines or users or outages to worry about. And now at pilot.com and previously at Dropbox, I'm sympathetic to the idea that spending a day on a weird bug is not like a uniformly exciting experience. On the other hand, if you have a bug to fix, you gotta fix the bug. And so I do think that there is a way in which you can like wrestle some delight at the opportunity to learn something, even when you're in a stressful situation under deadline finding out a bug. In the last couple of minutes here, I want to talk briefly about this research in the context of imposter syndrome. So imposter syndrome, if you're not familiar with it, is the feeling that you are secretly a fraud who will be uncovered at any moment. And this is a very common thing, affects people of all genders in tech and elsewhere. And it's an extremely painful experience for a lot of folks. And so Dweck's research is really interesting because one of the things that she shows is that confidence is not a good predictor of how well you will do at responding to new challenges, things that you have not encountered before. It is a good predictor of how well you'll do at things that you already know how to do. And it's also not a good predictor of how you'll respond to setbacks. So confidence isn't a good predictor. Another thing that's not a good predictor is prior experience at like doing something else, prior successes. The thing that is a good predictor of your success in the face of new challenges and in the face of setbacks is having a growth mindset. So this is really exciting to me because I think often the narrative around imposter syndrome centers on confidence. People say like, oh, how can you have imposter syndrome? Like, you're good, you should just feel more confident. which is, first of all, don't feel that way is like not usually useful advice as advice goes. But it also is using this framing of confidence that doesn't even get you the answer. Like for us as programmers, it is mostly new challenges, and I would say like mostly setbacks, like mostly failing tests, and then finally green, and then like red for the next 100, right? So a much stronger framing here is to say, the way to get better as a programmer is through exerting effort. Struggle is expected. Struggle is good. Similarly, bugs are expected. Bugs are good. And to embrace the idea that you are going to have to work hard, you are going to have to flail a fair amount of the time. And so again, if you're someone who believes that some people aren't cut out for programming, for example, you will spend a ton of time and energy in just overhead cognitive cycles trying to convince yourself that you are one of the ones who does belong. And so it's much more powerful to say, everyone can get better at this by exerting effort, and effort is expected as a way to grow. You reframe this around struggle and around growth. Carol Dweck has 2 books, if you're interested in more of this. The first one is Self-Theories. It's a collection of essays, and this has got more depth about the underlying science. She also has sort of a popular audience one called Mindset. I tend to prefer the former, so if you're interested in this, I recommend that. Okay, so love your bugs. They are a great opportunity to learn. They can be fun if you let them. You can share them with your friends and delight and amaze them. And also make sure that you share them with me. I would love to hear about it. Quick thanks to a couple of folks who gave me some feedback: Sasha Lundy, Amy Hanlon, Julia Evans, and Julian Cooper. And now I'm happy to take questions if we have time. And if we don't, I'm happy to take questions elsewhere. One question, and then I'll be around, so don't feel pressure.
Okay, so if no one has, I do have a question. So you did convince me this side. The part which I'm having a hard time is to convince my product owner to love my bugs.
Right. Yeah. I think this is a challenge. And there's also a context in which you can apply this and a context in which you can't. So I don't want to say that this is a great idea if you're writing like embedded systems on pacemakers and that sort of thing. You need to have a system that supports the level of complexity that you have. I think for a lot of tech companies that are doing consumer products, the like Facebook style move fast and break things is actually the right orientation, that like a lot of bugs are not that important, and so it's okay to have those pop up. I do think that product managers are maybe not the right audience for your like delight at learning something new about how the kernel behaves and that sort of thing. I think the most important thing there is a healthy process and like expectation setting. Yeah, that's about the best I can give you on that one.
Thank you very much on the answer, and thank you
so
guys for attending.
I'll be over here if people want to have more questions.